Kansai International Airport has not lost a single piece of checked luggage since it opened in 1994. It has, however, lost something else: 45 feet of elevation. Since construction began in 1987, the airport has sunk over 10 meters into Osaka Bay. The most optimistic prediction was over 5 meters over 50 years. Kansai blew past that within a few years of opening. So, if the ground won't stop sinking, why does Japan keep building on top of it? Because it already spent $20 billion, and there's nowhere else to go. Right now, 900 hydraulic jacks hold the terminal level. Workers insert steel shims every 2 years to keep the floor from tilting. The runways aren't rigid concrete, they're flexible asphalt, designed to bend as the earth shifts beneath them. And in 2007, knowing all of this, Japan built a second island. That one sinking 3 times faster. On paper, this should have been abandoned decades ago. In reality, Kansai just finished a $470 million renovation and handles over 30 million passengers a year. So, what happens when the world's most precisely engineered country builds its most important gateway on the worst possible foundation? To understand why Kansai sinks, you have to understand what Kansai is. Osaka's existing airport, Itami, was overwhelmed. Noise complaints from surrounding neighborhoods were fierce. Expansion on land was impossible because Osaka, like much of Japan's Kansai region, is hemmed in by mountains and dense urban sprawl. Planners looked at what happened at Tokyo's Narita Airport, where farmers and activists waged violent, years-long protests against land seizures, and concluding that building on land would be politically untenable. So, they looked to the water. 5 kilometers offshore in Osaka Bay, engineers proposed creating an entirely artificial island. The concept was audacious: dump millions of cubic meters of soil into the bay, create a flat surface large enough for a full-length runway and terminal, then connect it to the mainland with a 3.7-kilometer bridge. No noise complaints, no land disputes, 24-hour operations in a country where most airports impose strict curfews. Construction began in 1987. Almost immediately, the problems started. The seabed beneath Osaka Bay consists of roughly 20 meters of soft alluvial clay, sitting atop hundreds of meters of diluvial clay, which engineers described as behaving like a wet sponge. Under the crushing weight of 180 million cubic meters of landfill, this clay began squeezing out water and compressing. Engineers had anticipated this. They'd installed over 1 million vertical sand drains on Island 1 alone, essentially pipes driven deep into the seabed to accelerate the drainage process and speed up the compression, so it would largely finish before the airport opened. The sand drains worked on the shallow alluvial layer, but the diluvial layer, hundreds of meters thick and far deeper than the drains could reach, was compressing on its own schedule. By 1995, 5 years after opening, the island had already sunk several meters. The most optimistic prediction had been over 5 meters over 50 years. The discrepancy was enormous. The airport later admitted that engineers simply couldn't believe that there would be such a difference between laboratory estimates and the actual rate. But the airport was already built, the budget was already spent, and so the project continued. When Kansai International Airport opened on September 4, 1994, it was the world's first airport constructed entirely on an artificial island. Renzo Piano's terminal, a 1.7-kilometer-long structure with a flowing roofline designed to evoke a wave, was immediately celebrated as an architectural masterpiece. The airport won design awards. It graced magazine covers. It became a symbol of Japan's technological ambition. What those celebrations glossed over was the extraordinary infrastructure required simply to keep the building standing level. Because the island does not sink uniformly, the center, where the weight of the fill is greatest, compresses faster than the edges. This differential settlement threatens to warp and eventually snap the terminal structure. To counter this, engineers installed those 900 hydraulic jacks beneath the terminal's columns, each one adjustable to compensate for uneven sinking. Every 2 years, maintenance crews assess the tilt and insert steel shims to re-level the building. It is, in effect, a never-ending construction project beneath a functioning airport. The runways, meanwhile, use flexible asphalt rather than standard rigid concrete. Traditional runway surfaces would crack under the shifting ground. The flexible material bends and deforms, accommodating the constant downward movement without compromising the surface that aircraft land on. None of this was in the original plan. These are adaptations, improvisations designed to manage a geological reality that exceeded every prediction, and they've worked, at least so far. The 1995 Great Hanshin earthquake struck just 20 kilometers away. Kansai survived with minor damage, its sliding joints absorbing the seismic energy. The airport proved it could handle earthquakes. What it couldn't handle was water from above. On September 4, 2018, exactly 24 years after opening day, Typhoon Jebi made landfall in the Kansai region. The surge storm overwhelmed Kansai seawalls and flooded the runways, but the real catastrophe happened underground. In a design decision that now appears almost incomprehensible, the airport's critical electrical infrastructure, its power stations, and its disaster response center had been placed in the basement. When the seawater rushed in, these systems drowned. The airport went dark. Simultaneously, a tanker ship, torn from its moorings by the storm, slammed into the Skygate Bridge, the sole road and rail connection between the island and the mainland. The bridge was severed. Kansai International Airport became exactly what its geography always threatened it could be: a stranded island. Approximately 3,000 passengers were trapped overnight, with up to 8,000 passengers and staff stranded in total. Convenience stores emptied, air conditioning failed. In the sweltering heat of a powerless terminal, travelers waited with no information, no transportation, and no clear timeline for rescue. The aftermath was politically devastating. Typhoon Jebi didn't just expose the airport's physical vulnerabilities, it exposed the fundamental absurdity of placing critical infrastructure below sea level on an island that was measurably sinking towards sea level. The Disaster Response Center, the one facility that needed to function during a crisis, was the first thing the crisis destroyed. So then, why, knowing all of this, did Japan build a second island? The answer traces a familiar pattern of institutional logic. In 2007, Kansai opened Phase 2, a second artificial island with a second runway and a low-cost carrier terminal. The justification was capacity. The original single runway couldn't handle projected demand growth, but the second island was built atop the same Osaka Bay seabed, the same alluvial and diluvial clay that had already confounded every prediction on the first island. And, predictably, Island 2 is sinking faster. As of 2024, settlement on Island 2 has reached up to 17.47 meters from the construction baseline, and it continues to sink at 21 centimeters per year, more than 3 times the rate of the now relatively stabilized Island 1. The original design called for the airport to stabilize 4 meters above sea level within 50 years. Parts of Island 1 reached that threshold within just 6 years. Without continuous intervention, projections indicate parts of the airport could reach sea level by 2056. Despite everything, Kansai International Airport is profitable. For the fiscal year ending March 2025, Kansai Airports reported operating revenues of 245.4 billion yen, approximately $1.6 billion, a 31% increase year over year. Net profit hit 36.8 billion yen, roughly $236 million, up 138% year on year. The airport is the primary international gateway to the Kaihanshin Economic Zone, encompassing Osaka, Kyoto, and Kobe, a region home to corporate giants like Panasonic and tourist magnets like Nintendo World and Kyoto's temple complexes. In 2016, a consortium led by Vinci Airports of France and Orix of Japan took over operations on a 44-year concession. They pay the Japanese government annually for the right to operate, while the government retains ownership of the land and, crucially, the liability for the sinking infrastructure beneath it. And that risk is not cheap. Over $150 million has been spent specifically on raising seawalls and reinforcing infrastructure following Typhoon Jebi. Electrical systems have now been relocated from the basement to elevated floors. The total cost of the airport, including construction and ongoing remediation, has been estimated at $20 billion or more, with some analyses pushing toward $40 billion when factoring in inflation and continuous maintenance. Yet, Japan continues to invest. A renovation of Terminal 1, led by architectural firm Populous, has been rolled out in phases. Domestic areas opened in October 2022, international areas in December 2023, and the grand opening took place in March 2025, just in time for Expo 2025 in Osaka. The project cost approximately 70 billion yen, roughly $477 million, and expanded international departure lounge and commercial space by 60%, while installing a centralized security screening system capable of processing 4,500 to 6,000 passengers per hour. Hong Kong's $18 billion airport expansion, built on its own reclaimed island, has drawn global fascination as a mega project pushing engineering limits. Kansai is the same story, but with a more visceral, more visual problem. Hong Kong is building outward, Kansai is sinking downward. Kansai International Airport will almost certainly not sink beneath the waves by 2056. Engineers will raise seawalls, adjust columns, and repave runways. The airport will host Expo 2025 visitors, process 40 million passengers a year, and continue to generate hundreds of millions in profit. But beneath all of it, the diluvial clay will continue to compress. The 2.2 million sand drains driven into the seabed nearly 4 decades ago cannot reach the deeper layers where the real compression is happening. No technology currently exists to stop it. The best Japan can do is keep measuring, keep adjusting, and keep spending. It is a monument to human ambition and human stubbornness in equal measure. A $20 billion bet placed on unstable ground, then doubled down on with a second island, then renovated for an expo, then expanded for a future that requires the ground to cooperate with engineering rather than geology. The ground has not cooperated yet. There is no particular reason to believe it will start. Japan's answer, characteristically, is not to abandon the fight, but simply to outspend it. Year after year, jack by jack, shim by shim, forever racing to keep an airport above the water that has been pulling it under since the day it was built. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?